everyone, and thanks for watching Edupedia World videos. This is the second video for the topic of logic gates, and we've studied the basic logical functions in the previous video. Now we'll see how we can use them to add two numbers. Now let's look at two types of systems and how addition is done in both of them. We take the binary system and the decimal system. And let's say we're adding 1 and 1 together. We know this basic function will come out to be 1, 0. That is how you represent 2 in the binary system. And let's say you have something like 6 plus 7, which comes out to be 13 in the decimal system. Now 0 here and 3 here, these are called the sum digits. They are the sums of the end digits, and 1 here and 1 here, they are called the carry digits, because they are the ones that are carried over. You do 6 plus 7, it will give you 13, 3 goes down and 1 carries over to the other side like you used to do addition in smaller classes. The carry digit is the one which is the most significant digit. Right. So we can actually draw the addition table for the addition in the binary system of two numbers. And this is C, which is equal to A plus B. But it won't just be C, we'll have two numbers, C and S. C will be the carry digit of the sum and S will be the sum digit. So you can have 0, 0, 0, 1, 1, 0, 1, 1. 0, 0 added together gives us 0. So both the digits will be 0. 0 and 1 will give us 1, which can be written as 0, 1. This is also 0, 1. This, however, is 1, 0. The sum of 1 and 1 is 1, 0. So using this, we can actually see that when we add two binary numbers together, the carry digit is always A and B, and the sum digit is always A XOR B, or the exclusive OR. If A and B both are 1, then the carry digit is 1, and the exclusive OR we saw the last time, it is 1 if both are different, and it is 0 if both are the same. So C is equal to A and B, and S is equal to A XOR B. So if somehow we were to create a circuit which had two input terminals A and B, and the terminals were taken in two different places. So first we actually did an A and B, and that gave us C, and then we actually did, this is A and B again, and we actually did an XOR of A and B, that would give us S. So whenever you have A and B, if A and B is the C, the carry digit, and A XOR B is the sum digit, then the result would be the sum of A and B. Don't confuse the sum of A and B with A plus B. A plus B is a way of writing A and B. This is the sum, and this is known as the half adder. And the half adder can add two numbers of value either 0 or 1, and basically two numbers of one digit each, and it is represented as the half adder AB. So A and B go in, and the sum digit and the carry digit come out. How are they created? How is the circuit created? The sum digit is A XOR B, and the carry digit is A and B. Now obviously the limitation of this is you can only add two numbers of one digit each. What if you wanted to add more than two one-digit numbers? In that case, we use what is called the full adder. And the full adder can actually add three numbers. So let me just draw the truth table first. It might get a little complicated. You have A1, you have A2, and then you'll have A3, the third number. So first we'll add A1 and A2 and get C1 and S1, and then we'll add that to A3 and then get C2 and S2, and finally C and S. And I'd like you to verify all these values. I try to explain them as much as I can while I'm writing them. It's easy enough to verify. You know how to add two numbers. That means you need to take 2 steps to add 3 numbers. So let's take first these combinations. 0, 0. We'll take 2 of them. In one case this is 0, in the other case this is 1. Then 1, 0. We'll take 2 of them. In one case this is, in the other case is 1. 0, 1. We'll take 2 of them. 0 and 1. And 1, 1. Which will give us again 0 and 1. I apologize if the lines are not straight. Yeah. So first we'll add these two, and then we'll add the sum digit to A3. So the sum of 0 and 0 will obviously give me 0. The sum of 1 and 0 will obviously give me 0 and 1. This will also give me 0 and 1. And this will give me 1, 0. This is something we've seen already. Now what we'll do is, we add S1 and A3 and get C2 and S2. We'll add these two and get C2 and S2. So in this case obviously there will be 0 and 0. Here it will be 0 and 1. 0 and 1. This is 1, 0. 0, 1. 1, 0. 0, 0. 0, 1. Right. And now we need the final sum digit and carry digit of these sums. Now we already know what the sums of these are. 0, 0 and 0 will give me 0. 0, 0 and 1 will give me 1. 1, 0 and 0 will give me 1. 1, 0 and 1 will give me 1, 0. Right. 0, 1 and 0 will give me 0, 1. 0, 1 and 1 will again give me 1, 0. 1, 1 and 0 will give me 1, 0. And finally 1, 1 and 1 will give me 1, 1. So from this what we see is that the final S in all of these cases is the same as S2. This and this S is the same as S2 in each and every one of these columns. Now so we can easily get S, that will basically be S2. How do we get C? So if you look closely, you'll see that C is equal to C1 plus C2, or C1 or C2. If C1 and C2 both are 0, it's 0. Only if one of them is 1 is it equal to 1. So C is equal to C1 plus C2, or C1 or C2, and S is equal to S2. And this basically gives rise to the full adder. I'm going to rub this now. So the diagram for it would be, you have A1, you have A2, you have A3. A1 and A2 are added according to the half adder. We've already seen what that is. And that gives rise to C1 and an S1. And then we take A3 and we take S1 and we add them together. In another half adder, and that gives us C2, and it gives us the final S. Final S is basically S2. And you take C1 and or C2, and that will give you the final C. So you add two of them, you'll get C1 and S1. You add S1 to A3 and you'll get C2 and S2. S will basically be S2, and the final C will basically be C1 plus C2, and this is represented as A1, A2, A3 going through the full adder, giving us C and S. This is the symbol for this. And once we can add more than 2 numbers, which is 3, we can actually add 4, 5 or 6 numbers. The only thing is the diagram gets more complicated, but conceptually it's just as easy. Right. So this completes logic gates and logical circuits. Thank you.